Hello, everyone. This is a fun episode because we are talking to one of my close friends, Dipti Borkar. She's a general manager and vice president of Microsoft Fabric. Microsoft, to me, is an enigma. How did this company go from being a laggard in the industry to being the hottest company with a valuation of $3 trillion, over $3 trillion, along with NVIDIA and Apple? So here we are. Dipti, thank you so much for coming to this episode. I am so happy that we get another chance to talk.
Absolutely, Sanjeev. Always a pleasure chatting with you. Great conversations. And I'm playing a very, very small part in this big Microsoft motion that we have moving forward here. But yeah, happy to talk about data with you.
Thank you so much. I saw you at Snowflake Summit. I saw you at Databricks Summit, and you have quite an illustrious career. So I don't want to steal the thunder. Can you please tell us what's been your career journey up to this point? Where all have you been?
Yeah, absolutely. It's I feel very grateful to have experienced a lot of different pretty dramatic changes, transformations in the data space. I started off in the database lab at UC San Diego a long time ago and been in data 20 plus years now across various different companies. IBM was DB2 distributed. Couchbase, I was there for a long time doing NoSQL. From there, moved to the disaggregated stack space in the analytics space, founded my own company, Ahana, exited that, and now back to a Fortune 50 Microsoft, just celebrating my 2-year anniversary this week, actually.
Oh, wow. So it's been 2 years?
Absolutely. Time flies when you're having fun.
Yeah.
Um, it's,
So,
yeah, go ahead.
no, after you.
2 years, it's been so incredible. I've been in this data analytics space even for the last pretty transformative 5, 6 years, as we'll talk about. And there's never a dull day, right? Every day there's more and more interesting things coming out. The beauty of it is that data has stayed the foundation and continues to be the foundation, even with Gen AI and even with all the different kinds of models that are coming up. Your models are only going to be as good as your data. And so it's been fun being a part of this kind of core foundational element that everyone is building on top of.
That is great. And we want to talk more about that. Before we go into that, you mentioned that you founded Ahana and then had a successful exit. Can you talk more about what was Ahana about and what was the exit?
Absolutely. When I was working very closely with Facebook at that point, Meta, Uber in the open source space, what I realized very quickly is a lot of the disaggregated stack at that point was extremely complex to manage. There were a lot of PaaS systems, and there was a lot of manual intervention needed, configurations that were needed. There was no SaaS experience. And so I founded Ahana really to kind of create that SaaS experience on data lakes and to enable interactive querying on data lakes. Ahana was exited to IBM. It was a successful acquisition. It's now part of the Watson X data family of their products, and great to see that all the good work and the engineers are part of the team as well, are happy and integrated into that product.
It's interesting you mentioned SaaS because now you're responsible for Microsoft Fabric, and I've heard you use the word true SaaSification. So what is Microsoft Fabric? Why is it different, and how is it true SaaSification?
Absolutely. So within Microsoft Azure Data, I'm responsible for the Fabric data dev experiences as well as the strategic ISVs. We're working with a range of partners. And Fabric is a truly SaaSified experience. So, what we mean by that is when you think of Power BI, right? You don't think about which cloud it runs on, whether is it an Azure product, is it on a specific cloud, whether you're on AWS, whether you're on GCP, you probably use Power BI. And that's because of the pure SaaS nature of it. Everything underneath the covers is hidden and taken care of for you. It's an application. And so we've extended this concept and this powerful principle to the rest of the data ecosystem. And that's the foundation of Fabric. So Fabric is a true SaaS experience. When you get started, it's really easy to start. There's no configurations. A lot of things are auto-tuned. You're not picking the services. You're not picking the VMs, right? It's all configured for you. And this is the beauty of getting faster insights from your data. Your engineers, your data scientists, your data analysts spend less time on the tooling and the configuration and the infrastructure, but more time actually deriving more data and insights from all the things that they have within the data platform.
Who is the ideal persona that uses Microsoft Fabric? Is it a data engineer, data scientist, or are you trying to unify all the personas, including data analyst, business analyst?
So it's a great question. I mean, the name Fabric says it all, right? Fabric is kind of the foundation, and it's a horizontal platform. It includes 6 purpose-built experiences, starting from Power BI to Azure Data Factory, to our data warehouse, to our data science, to our real-time intelligence as well. And all of these are part of a single platform. So within Fabric, it is built for multiple personas. Data analyst, of course, which is on the reporting side. You have your data engineer. We have Spark out of the box, notebooks, data scientists, warehousing engineers. And so it is for a range of personas across the board. There's also governance built in. And so we certainly work with a lot of data architects as well as data stewards.
So what you're saying is that instead of me having to go to Azure Data Factory to do my data ingestion or integration and Azure Databricks and Synapse and Power BI, now I have a single pane of glass, and through this unified experience, any user can go and is it like no code, low code, drag and drop and build my entire pipeline?
Absolutely. Clicky, drag and drop is often used in what we do. It is absolutely low code. Let's leave Microsoft out for a second. If you were to build a data stack with the products out there, you would probably use Snowflake for your warehouse, maybe Tableau for your reporting, maybe Spark or dbt and others for your ETL, Fivetran for moving data around. In this case, with Fabric, you get everything in one product. So you actually buy one product. You don't buy 4 different products or 5 different products. You buy a single product, and the business model, I think, is the one of the most transformative things of Fabric. You don't over provision each of these line items. You buy a single product. Typically, you would have to, most customers over provision each of these, need to manage each of these separately. There's different subscriptions for it. With Fabric, you get a single product. It's a SaaS experience, low code all the way to pro code with notebooks and the data engineering built in. And you buy a single product. So you buy a Fabric capacity that you could use for any of these, each of these built serverlessly on top of one lake, which is the foundation.
Got it. So we want to talk more about one leg and geek out a bit. I know you love to do that. So, but before we do that, I'm just trying to understand the scope and enormity of Microsoft Fabric, because you got Azure Databricks, which is a native service. What is the connection between, I saw there were some announcements at Snowflake Summit and at Microsoft Fabric Con with Microsoft Fabric and Snowflake. What is that connection?
Absolutely. So good question. Look, when we talk to customers, and I've talked with, over the years in the analytics space, like hundreds of customers, and all of them are really looking for a few key elements. They want data to be open, right? And they want interop across systems. So when you talk about whether it's Databricks and Snowflake, both great products, with Microsoft Fabric and OneLake, what we've built essentially is deep interop, so you can use whichever engine the customer might want. Data that might have been written from Azure Databricks in ADLS can be accessible through Fabric. You might use Iceberg as your format within Snowflake, and it can now be accessible through OneLake through our shortcut mechanism in over later this year. Again, bringing an immense interop for customers so that they're not locked in one place. And what OneLake then gives you is a complete data estate that you have a view on. You don't have to move your data, right? You can actually shortcut symlink this, and we've talked probably about this a little bit. But this is the deep interop that we're building to give customers that optionality. They have a choice to use the best of the engines that might fit their workload. Of course, Fabric offers a range of options, extremely wide across these range of different data workloads. But the customer is in a good place because they get open formats, so they're no longer locked in, and they have complete interop across these systems. And in that way, Fabric is unique. It's the only platform that allows this level of interop across data platforms, but not just data platforms, across clouds as well.
So if I have a hypothetical example, so let's say I am analyzing some data which is sitting in Databricks, Azure Databricks, but there are certain aspects of the data that sit in Iceberg format on Snowflake. So can I enrich my data in Databricks and write it to OneLake by querying Snowflake? Like, how do these things interoperate?
Absolutely. So let's say you have data in Azure Databricks, even
Yeah.
in ADLS Gen 2, maybe not in OneLake, that gets shortcutted into OneLake. It's now viewable, accessible, but it's not a copy. There's still only one copy of it in ADLS. You have Iceberg data in Snowflake. Let's say it's sitting in S3. It can be shortcut into OneLake,
Okay.
viewable and accessible. You
Right.
can open a notebook and you can write a SQL statement across data across both these systems and run it. So not only does it and you get a single view of your data, you can federate across. But we also have caching built in. And so OneLake has a cache so that you're not constantly pulling that data in. Most of these analytics cases may be slow moving data, and so it works perfectly well.
So I can then do create table as select from these two shortcuts. One is coming from ADLS Gen 2, one is coming from Snowflake, and then I can say, okay, now create table, and that table will become a delta table.
You don't actually even have to create a table. So when this data
Yeah.
lands as shortcuts,
Yeah.
what happens is it automatically turns into a lakehouse
Ah,
within Fabric.
right.
And when it's a lakehouse, it automatically gets a T-SQL endpoint on the top. And so you essentially have a query engine. So you write SQL to it. So there's no real table management maintenance that's needed because we build that up for you. And once it's in a certain folder structure, it automatically becomes a lakehouse. So yes, you could do CTAS and some of these other statements, but it actually is not needed because T-SQL endpoint comes pre-connected to every lakehouse.
Yeah, very interesting. So we're talking about shortcut, which is a symbolic link.
That's
And
right.
so this is like federation or data virtualization.
Yeah, I mean, you can think of OneLake as OneDrive, right? We
Yeah.
have OneDrive for documents in Office M365, and you have various ways of accessing all those documents. You have Word, Excel, Outlook, and so many other product offerings, all packaged into M365. Now, in some ways, Fabric extends that model with OneLake as OneDrive for data. And all of these workloads that are tightly integrated in it. Of course, it took a little bit longer to adapt every engine and so that it understood Delta Lake format natively, which is like a little bit of performing open heart surgery, if you will, on the distributed systems. But it's built to do that. It's that unique experience where you get multiple engines, one lake where you have a full view of the data built into a single product.
Very interesting. I love this. One lake is like OneDrive, but for data. Uh, Data in the sense like data as we understand structured data, not documents. That's also data.
That's right. That's right. Or
So
you could have, images increasingly for AI, semi-structured, unstructured data is becoming more and more important. And so you could have files, the symlinks and the shortcuts work a similar way. You can pull in blobs, you can pull in images, and then you might want to run AI search or vector search on top of OneLake, and that is supported as well. So you get, you have the full view breadth of not only Fabric, but also our Azure AI ecosystem that's tightly now connected with OneLake.
one of the problems in data virtualization, and I've been following companies like Denodo, and before that, during the Hadoop times, there were all these companies that were doing virtualization. It's been performance because you are at the end of the day limited by the speed of light, and if you're going to different systems and trying to join them, how's the latency performance of these shortcuts?
Yeah, so that's a great question. And it depends on your workload, right? If your queries are, very selective queries and hit a certain part of the data, shortcuts can be a really great mechanism. We also have caching that obviously helps with performance, and it makes it very much more effective. So you're not paying, let's say if it's in another cloud, you're not paying egress costs. But we also have another mechanism. So, we understand that in some cases, either the format itself is not open. For example, Snowflake native format, you can't read it, right? No other engine can actually access it. And so the only mechanism you can read it in is their CDC feeds so that you can actually replicate that data across. So in some cases, you might want to create a copy of that data, and we call this data mirroring. So data mirroring into OneLake is another great option that's also available. And we've started off with Snowflake to begin with, and we'll have other particularly databases that can be mirrored into OneLake. In this case, you are creating an incrementally updated copy in OneLake, so you have the full copy. This is continuously updated, so there's zero ETL involved, and you get the benefits of all the updates being reflected. We also have this available for our own Azure SQL and our Cosmos DB offerings. So customers who have their OLTP databases can now have these trans-analytical applications perhaps built where the data is automatically landing in OneLake, and they can then use it for direct lake with Power BI, or of course use any of the other engines on top.
This is amazing. So we have both the options. So we've got shortcuts, which is federated virtualization, symbolic link, and we've got mirroring, which is a real-time chain data capture replication. And you have it in GA. Snowflake is general.
It's in preview right now, and yeah, we will. We don't diverge before our conferences, as you know, Sanjeev.
No, absolutely.
But very strong roadmap there, and I'm personally very excited about it because it will allow ISVs to do a lot more with OneLake as well.
Very, very cool. And what is the mechanism by which the chain data, is it Kafka underneath it just, or is
Yeah,
it?
so we have our own replicator. In this scenario, we don't use Kafka. We plug into the CDC feed, but we do have real-time intelligence, which is a full-fledged offering on Fabric that we recently announced at Build. You can get notifications from any part of Fabric itself, even OneLake, or any of the other systems can be plugged in into real-time intelligence. And we support Kafka, we support the kind of a pub/sub model. There's multiple variations. We also have a time series like database with Kusto, which is extremely powerful. All our telemetry, the petabytes and petabytes of telemetry across Microsoft services lands in Kusto. That's how production grade it is. Extremely, it's a I would say planet scale system in some ways, given the scale of data that we support across all of these services.
Yeah, so every Windows PC, when there's a telemetry information is stored in
The
Kusto,
service information, exactly, from
which
variety of Azure services lands in Kusto.
which is like petabytes of,
Petabytes and petabytes, hundreds of thousands of petabytes.
right.
It's a very large system, mission critical, as you can imagine.
Now, the native format for OneLake is Delta, correct?
That's right. So
Good.
given our Azure Databricks offering, we started off with Delta Lake. We have a lot of customers on that today. And, as the native format for the engines is Delta Lake as well. We have some optimizations on top. So for example, the sort ordering is something that we've added on top for higher performance. So these are some of the tricks why Power BI can now do direct lake mode and can access this information without even an engine, without a SQL engine in the middle. So you can, that's what we call direct lake mode. You can do direct query, and that typically goes via a SQL engine, right? Now, in addition to that, we said, well, a lot of our customers are also asking for Iceberg. Snowflake is a very big and important partner for us. And that's how we announced Iceberg support a couple months back. Super excited about it. I think in the market, there's very few large vendors that support multiple formats, and so we're thrilled to be able to do that all through open source using Xtable, which will allow us to essentially interop across these two formats.
You got it. So when you read from Snowflake and you mirror it into OneLake, so how is the translation done from either Snowflake's proprietary format or Iceberg into Delta? What is that translator?
Yes. So great question. So when you're mirroring, or when you are, let's say, ADF or data factories, let's say, landing some data, it directly lands it in Delta Lake format, so that you can automatically get this lake house that I talked about pre-created for you, so that you have a SQL endpoint already attached, and you can just start writing SQL queries, right? So it is optimized in that way. We're taking care of all the pipelining. Typically, you would have written all these pipelines to write it in an efficient format, write it in the right sized files, because small file problem is pretty prevalent in Parquet, as most people know. So we write it in the right file format, the right size. We optimize it with our own sort mechanisms, etc. And that's what you get out of these out-of-the-box mechanisms. So really, the user doesn't have to do much. It's a couple of clicks, and you're ready to go, and you have a lakehouse based on your Iceberg format, right, or your native format if it's replicated.
So this is good to know. So basically, users don't have to worry about it. Azure Data Factory or whatever the underlying engine is going to automatically do that conversion.
That's
it's
right.
all behind the
That's
scenes.
right.
Microsoft and Google also have partnered to create something called Apache Xtable. Where does that come into the picture?
Yes. So that comes in when we have shortcuts, and when you're shortcutting Iceberg directly into OneLake. So Xtable essentially is the interop between Delta and Iceberg. Fundamentally, the metadata is written in different ways, right, to keep it simple. And so essentially, it allows for translation of the metadata into a different format. So that's what we will use internally to actually convert Iceberg and make it available in Delta. And this is done at runtime. So it's not it is from a performance perspective, it can be extremely performant. The engines then use Delta underneath the covers, and can query that or leverage the Delta Lake format that it has been converted into.
So Xtable is used at runtime, and it's interoperability between Iceberg, Delta, and Hudi.
That's right.
And when the write path happens, then the Azure Data Factory is writing it into Delta on its own. So the write and read are using different
Yes.
mechanisms.
So it depends on who is writing the data. There are many different engines. They can all write data. Typically, we have a single engine to write, and multiple engines or any engines can read, right? So that's the approach that's used. I think that, when you look back, all of these open table formats are great, right? And but there is, when you look at databases and transactionality and how that will evolve over time, there is still a long way to go for these formats to sort of achieve that level of transactionality, concurrency. Even now, a lot of it is optimistic concurrency, and the mechanisms, I would say, coming from our database background, are pretty rudimentary. And what OLTP system, SQL Server, for example, state of the art SQL database. We have a long way to go to catch up to that kind of model, where it's distributed transactions or multi-statement transactions even. There's more research to be done there. And I think over time, these formats, and they are evolving. I think the newer definitions and the Delta 4 format update was just recently published. This will evolve over time. Hopefully, they bring us to a point where we can have some of this, transactionality built on top, and we move away from a mode where we need to manage single writer and multiple readers.
Yeah, yeah. So that's such an important point, because these table formats have read compatibility, but the writes are very, very different. And so it's still single writer. So you have one native format, but then you can read it in others. In fact, Databricks also has a product called Uniform with capital F that does this read compatibility or read interoperability.
Yes, it's similar to Xtable in that way. And so over time, I think these may converge. With Xtable, we are founding members. We're very proud to kind of have this open sourced. So we're pushing for a lot of the Delta integrations into Xtable. That's the work that's ongoing right now. Of course, the Hudi folks are sort of helping with the integration with Hudi. And over time, we will have more Iceberg integrations in as well. It's ongoing right now. So the Xtable is these, especially when you need, some clouds have to support multiple formats, right? It's just the customer base is so large. We do need to support optionality for our customers, right? And so in that, there's two ways you can do this. You can either build engines and have them support both natively, right? And this is kind of a meta principle level discussion, or you can go through a translation mechanism.
Yeah.
Supporting every engine to do both natively is a lot of work. So it's hard enough to get a single format supported end to end. And we believe that we can actually abstract away some of the base level translation can be done within Xtable, but the rest of the optimizations can be in the engines themselves. So there are more to come there, but we're thinking about this hard, yeah.
Also, writing to multiple formats is also very high overhead, very high latency, because you cannot commit a transaction till it's written to all the formats, and that just adds to latency. So
yeah, so we're sticking with one format within the engine, and then outside of that, we have the interop at the runtime to convert Iceberg to Delta, or when it's reading it to convert Delta to Iceberg. Yeah.
that is great. So we've talked quite a bit about the write. Let's talk about the read, the compute engines.
Yes.
Is there a native compute engine of Data Fabric that's preferred over others, or can I bring any compute read engine?
Yeah, great question. Now, OneLake itself has its own APIs. They're open APIs. So if, in Delta Parquet, you can have other engines that work directly on top of OneLake, right? Now, within Fabric itself, there are 3 core engines, I would say, maybe 4 core engines. Spark is one. This is part of our data engineering experience. And most recently, we announced a native Spark engine which is using Velox and Gluten as the open source, popular open source projects as part of our Spark. So it's C++, and so it's highly efficient. We moved, the core engine is moved from Java to C++. We have our warehouse, which is Synapse. This used to be the Synapse data warehouse. This has been completely rewritten to switch it to a disaggregated mode where you have storage is separated out in one lake, and you have the compute engine, which is now purely serverless, and you get a state-of-the-art warehouse, which is a distributed cluster essentially running SQL. And so those are the first two. The third one is Kusto, as I mentioned, and that is great for time series data, windowing kind of queries, right, where it's in memory. It has an in-memory footprint. It's very, very fast, low latency. And so if you have low latency use cases, that's a great engine. And then Power BI itself has analytics services that is part of the Power BI engine that can now natively read data as well, and can serve these into reports within Power BI. So there's multiple engines. Data Factory internally, underneath would use Spark for a lot of its transformations, and we're adding more and more. So last at Build we announced GraphQL support, and so now GraphQL can be an API that's used on top of the warehouse or the lakehouse, and you can directly expose a GraphQL endpoint that our customers can now use.
So is Synapse going to be the term Synapse? Is that still pretty actively used within?
So Synapse was our data warehouse. Fabric is the next generation of Synapse, essentially. So most Synapse customers, if they haven't already moved to Fabric, it's a matter of time before they will upgrade essentially to Fabric. Prior to Fabric, before we had a name, it was just V Next for Synapse, and so it's just one of the engines. I would say it's a pretty foundational core. We have very, very large customers that are deploying on top of SQLs. And so SQL in Fabric is essentially the Synapse vNext. And that's their core workload that they're using, is the data warehouse.
I've seen some architecture diagrams where Synapse is used in multiple different places. That's why I was wondering, is Synapse a brand that you promoting or
Yeah, great question. Here is where I use the principle. Naming is hard. Caching and naming are the two hardest things in computer science. Honestly, I think initially we were using it. I think increasingly we're just within the Fabric experience, it's the data warehouse. So when you say Fabric data warehouse, it's essentially the historical Synapse. I think over time, I don't have the latest on that. So but I think over time, we will just be giving it, calling it the workload names that they are. So data engineering, for example, is Spark. Data warehouse is the SQL warehouse, and so on. Yeah.
So this is great. I want to in fact go back to the Spark. So just to recap, so the 4 native engines, you can bring your own if you want, like Pandas or DuckDB, I'm guessing.
Yeah, absolutely. DuckDB. I think there's plenty blogs of DuckDB on OneLake as well.
Oh, wow. Okay, interesting. So the 4 native ones are Spark, Synapse or Data Warehouse, Kusto for time series, Power BI, and then
ADF is obviously there. That's part of it. Yeah.
I want to go back to Spark because you mentioned Velox and Gluten.
Yes.
These are not that well known. What are these?
Yes, so it's a great question. So Spark fundamentally, as an engine was written in Java, right? And Scala and Java. And so it can only be so efficient from a GC perspective, a garbage collection perspective. Velox is a library that Meta essentially open sourced. They use it internally for both their Spark as well as their Presto deployments. And what it is a set of operators that is essentially SQL operators that are now written in C++. So they're highly efficient. So you can think of it as a runtime that's a C++ runtime that a SQL engine can use underneath the covers much more efficiently, both from a latency perspective and also a CPU utilization perspective. So, we've seen a range like when we run TPCDS, significant improvements in terms of both CPU utilization. That means you're spending less. You're buying, a little bit less fabric capacity, right? And getting faster query results. So what essentially we've done is taken the Spark engine, we've embedded Velox in there. Gluten is a layer on the top, which essentially abstracts away allows for syntax and the I would say compatibility on top. So you have Gluten on the top that abstracts that away. You have Velox in the middle, and then that's how you get the efficiencies from Spark. So essentially, that's the native engine, the new native engine, and we've seen it perform, very well. Yeah.
That is great. So Velox is open source from Meta.
Yes.
And
Gluten is open source by Intel.
oh wow,
Yes.
okay. So Meta and Intel are both
Yes.
involved here. Okay, so this story is coming along really well. Thank you so much. So you already clarified, demystified so many of these components. So moving above from read, so let's talk about security. So the question I have is, let's say, I have some sort of policy definition on who's allowed to read Snowflake tables, but now I have a mirroring or shortcut into one lake. How am I making sure there's a consistent enforcement of read-write policies, data access governance in Microsoft Fabric?
Yeah, great question. And the same applies to any any engine that accesses data from a different platform or a different engine, right? Typically, if you do storage level access, right, then you need to define your governance rules, your policies in two places, because you're sharing a store at the underneath, right? And you're sharing storage in some ways, whether it's shortcuts or whether it's files. So you have to define the policies on the top. So in this case, let's say you have Snowflake, Iceberg on one side, Fabric on the other side with one lake, and you have shortcuts. There's two mechanisms. One, if you use our SQL warehouse, you have extremely fine-grained access control that will allow you to define the policies, etc., within the engine itself. And so each engine has its own governance tier, which can be, you can go down to, RLS and so row-level security, and so on. We are also introducing in one security, which will sit on top of the storage tier itself, so that other engines and all engines have to adhere to that storage tier concept of governance. And then, of course, across all of these data platforms, we have Purview. Microsoft Purview is our governance and metadata offering that goes across products, even outside of Microsoft. And so you can have Purview policies that manage Snowflake, Fabric, and Databricks. So there's multiple layers, if you will, of governance that can be built in within the core engine. It can be at the storage tier, and that's something that we're working on, which is one security, or across everything, which is Purview. And a lot of customers do all of these, right? Because it is for increasingly, especially for FSI, for healthcare, EMR records, they may want to have multiple layers of security. They have and may have policies defined in different places.
I see. So, policies also defined in, if you use Databricks in Unity Catalog.
Yes.
And we were at Snowflake Summit, we learned about Polaris and Horizon. So what is the connection between Microsoft Fabric with Purview, and then there are these local catalogs
Yes.
in their own environment? How do they all
Yes.
come together?
Yeah, so that's a good question, and it'll keep getting more complicated as more
Yeah.
catalogs emerge over time. There's two kinds of catalogs, right? There's operational catalogs, which
Mhm.
are actually used to query metadata, schemas, things like that.
Technically.
A system catalog, right, if you will.
Yeah.
Now, in the database world, it used to be part of the database. In the lakehouse world, it's been pulled out of the database, right? It's actually outside. And Hive Metastore is the perfect example of an operational catalog, but not a governance catalog. What's happening is over time, like Unity Catalog as an example, has merged both the operational catalog and the governance catalog into a single catalog, right? So not only is it used for schema, system schema information. So you want to see, okay, which tables do you have? How many catalogs, which schemas within each schema, how many tables do you have? That comes out of the Unity catalog. But you also have governance that's built in. Now, as part of our integration with Azure Databricks, what we have done is if customers use Unity Catalog to define their governance, and they want to use, let's say, Fabric for whatever reason, we will be adding, and we demoed this at our FabricCon as well as Build, where we showed that we have a Databricks item within Fabric, which can automatically create shortcuts to ADLS Gen 2. So you first have shortcuts and access to the data. And secondly, as users go and access this, they get tokens from Unity Catalog. And so you essentially create shortcuts with the same governance that you have within Unity Catalog. So that's the mechanism we have sort of used in this case as an example, so that users can have access to what they have access to within Unity Catalog. Over time, similar mechanisms as integrations get built need to be thought through to make sure that if a customer wants to use a governance model A in platform B, that's possible. Or if they want to define a different governance model B in platform B, that's possible, right? So customers are looking for flexibility. And the same thing will, emerge here where I think we will see different types of requests. I want to define policies in both places, in both platforms, or I want, governance of platform A to adhere to apply to platform B. I think that is much harder to do because the code bases are just so different. In this example that I gave you with our Databricks artifact, we actually were able to do that, partnering with Azure Databricks. And of course, then there's Purview, which is sort of global governance across everything. We have our core platform sort of governance built into Fabric, but of course, customers may want to go beyond that.
Yeah, that is amazing.
It's complicated. It's a lot to consume, but
It's a lot.
hopefully I've been able to
Yes.
explain it
Yes,
parochially.
we would need to have another session just to talk about security. But for now, in the interest of time, I want to move to another. So I feel like I'm peeling the onion and asking you about different. So the next layer that I want to talk to you about is the DevOps or data ops. And what features, capabilities exist in Microsoft Fabric for things like orchestration of jobs, CI/CD, automated testing, workflows, notification, so all the data ops capability.
Absolutely. Yeah. So that's a very big area, right? And a very important area. And I think that it's also one that we're innovating and continuously delivering in. So my answer today is literally will be different tomorrow and even in the short term. There are CI/CD is built in. So we have a concept of workspace in Fabric. A workspace is a very important concept because not only is it folder structure in one lake, right? That's you kind of get it. But it's also a project. It's also where you collaborate. You can, within a workspace, you can have a lake house, you can have a report, you can have a Kusto database, right? You could have a notebook. So it's kind of a project, a data project in some ways. And a data project, you will want to version and you will want to have different environments for. So every workspace can be be a dev environment, it can be in staging, it can be prod, and so a workspace itself has multiple versions, and you can define what whether it's dev or prod and so on. We also have a range of APIs. So all our APIs can then be used to integrate with maybe third-party products if you want to for your automation capabilities. And underneath the covers, from a integration from a pipelines perspective, we integrate with ADO, right? So ADO is our current offering. So Git, it supports Git essentially, and so Azure DevOps is our first party offering that we've started off with. And in the future, we have obviously Git is a protocol, so we support Git, but then there's GitHub and various other mechanisms that we are looking into and adding as well and are part of the roadmap. In addition to this, ARM and Terraform are also very important from an integration and automation standpoint. So every workload may be in different stages of integration with these tools, I would say, DevOps tools. So that's something that's in some cases it's in Purview, Preview. In some cases, it's available. In addition to that, we have VS Code integrations, which are required for coding artifacts. So notebooks, for example, have VS Code integration so that you can, open it in a local environment because you're, as a developer, you want to have your desktop, right? I want to have a local environment, and that is a part of kind of the DevOps as well. So you build locally and then you push it into back to Fabric into the SaaS environment. And so that's another area that's evolving, I would say. So many different areas in many of these dimensions, still more work to be done. And honestly, the customer requests keep coming in, so we manage these roadmaps. The beauty of a SaaS product is you keep delivering. It's not quarterly or 6-month or annual deliveries. We ship our roadmap updates come out monthly. We ship weekly. And so the pace of innovation is just furious.
Phenomenal. Yeah. So Dipti, we've gone literally from bottom storage or to compute to DevOps, security, catalog. So now we've reached the top. So now I have my Azure DevOps ADO capabilities. I have notebooks and I have a workspace. Now I'm going to create my data products. Or maybe I want to create a AI agent or a chatbot or assistant, but I need a common understanding of everything beneath. So is there a semantic layer? And then what is a Gen AI support on top of Microsoft?
Absolutely. So that's a great question. Gen AI plugs in at various different points, right, in the system. Let's start off with the semantic layer. And the semantic layer for Power BI and Fabric is a semantic model. So it actually has a semantic model. And the Power BI Copilot leverages that. You have Copilot built out of the box. So you can ask a question to create a report on a set of tables, and it just does it for you. And you can evolve that report, add more data, add more tables, change the visualization, all with just Copilot. So that is now, it's available, and I would say it's more about data analyst or end user productivity. That's really around productivity gains. But the second question we get is, great, we want to get our team to do more with less, right? That's the phrase, a hot phrase these days. And so your data engineers, your data scientists, they all have copilots. Every experience within Fabric has a copilot, right? But what about end customer value for the enterprises? And that's where custom copilots or custom models, AI search, or vector search and other things come in. And this is where they say, hey, we have our own proprietary data. We actually want to build our own custom Gen AI models on top of our data and monetize it. Monetizing it could be, and featureize it, if you will. It could be customer support, where we want to improve our customer support value. It could be packaging new products altogether and making this available to their end customers and actually creating new offerings. And that's where OneLake comes in. So OneLake, because it supports files, it supports structured, semi-structured, unstructured data, you can have many different things that work on top of it. As an example, I mentioned vector search. So vector search, Azure AI Vector Search enables both vector indexes, but it also has your more traditional keyword-based reverse index. And then it actually combines those two, ranks them, and gives you even better results, right? So you don't have to bet on one or the other, because some prompts are better with vector indexes, but some prompts may be actually better with traditional keyword-based indexes. So this now directly integrates with OneLake. And so when you create your vector search, all you need to do is give your OneLake endpoint, and it's indexed for you.
I see.
And so, and then you can build applications on top of that, Gen AI applications, and so on. Same thing with Cosmos DB. So Cosmos DB comes with vector index. SQL now has a vector index. Both these, as we were talking about it earlier, can be mirrored, and their data lands in OneLake. And so your app you can build using the OLTP systems. But guess what? All of this data is also available via analytics, and you can combine the best of analytics and your OLTP systems into these Gen AI applications.
Very, very impressive. Can I bring my own vector database, an open source vector database, or embedded vector database, or
Yeah, if it supports ADLS Gen 2, then by default it supports OneLake, and so it would just work out of the box. And so it depends. Most vector databases tend to be very database, like operational database centric. But increasingly, data is in S3, ADLS, OneLake, GCS, and so they will have to support more and more of these broader object stores, if you will, and over time these table formats, because that will be the predominant way that data is stored, and especially the cleansed data, because your model is only as good as your data, as we said earlier, and the cleaner, the more governed your data is, the better the model will operate, and the more efficient your results will be. Now we also have AI skills within Fabric, so if you have prompts, you can actually fine tune those the prompts, and customize the prompts and say, okay, for this set of questions, actually that's the wrong answer, this is the right answer. And so we have a lot of things built in from a Copilot AI skills perspective. And honestly, I feel like it's just the beginning. Every day I myself learning a whole set of new things, and on talks like this, educating the world.
I tell everyone we are literally discovering we are on a journey. We don't have all the answers, but day by day, we learn more and we refine, and we have the right to change our opinion because we live in such a dynamic world. There's no need to be religiously fixed to a certain point of view because tomorrow that may change.
Absolutely. I mean, honestly, the one thing that I've learned over 20 years in data is change is the only constant. You better keep learning and evolving. And it's
Yeah.
both a self-transformation,
Yeah.
where you're constantly learning, as well as technology transformation. And those go hand in hand. Honestly, you can't have one without the other. You need change makers to actually make it happen.
So that's such a great way to take us to the very last question. We've reached the end of our time here because I wanted to ask you, what are some of the key lessons that you've learned in life, and what message would you give to people who are in a space, and some words of advice?
I mean, honestly, I'm still learning myself, Sanjeev. So not sure how much this advice is good for, but I'll say it out loud so it applies back to me. I would say, constant learning. It really is important to be curious,
Hmm.
right? Be curious. If you don't know something, ask ChatGPT. There's no excuse anymore.
Right. Yeah.
Like you have to constantly learn and connect the dots to see how it's relevant to your world, right? You can learn, but unless you apply it and make it relevant to your vertical, your company, your project, it's of no good. So step one, curiosity, learn. Step two, application, and connect the dots to making use of it in your world. And I would say Step three is, like you said, you can have firm principles. Core principles are important. Honestly, when I look back at, we were doing indexing, different types of indexing, different types of caching 20 years ago. We're still doing different types of indexes, different types of caching. The environment has changed around it. So apply the principles, but apply it in a new way, with an open mind. So you actually get better benefits from that application. They say history may not repeat, but it rhymes, and you kind of have to look back. You can't replay exactly what it is, but you can certainly learn from it and rhyme it in your own way.
Amazing. Thank you so much. This has been such a fun podcast. I didn't expect we would geek out so much. I had all these questions about data mesh, data fabric, your views on open source, but we didn't talk about any of that. We just went straight, dived into data fabric, Microsoft Fabric. Thank you so much. I've really, really enjoyed having talking to you and learning so much today.
Absolutely, Sanjeev. Thank you so much.
Thank you. See you everyone next time. Take care.
Thank you. Bye-bye.